page 75 when we're done. We are going to find the area between two curves, okay? So instead of just the area between a curve and the x-axis like we've been doing, that's what we do when we integrate. So let's say that we have this, okay? We'll let this be function f, okay? Just something kind of like that. And we have found the area between the function and the x-axis. That's old news, right? Between, like, on some interval or whatever. But let's say that we have another curve that looks something like this. Okay, we'll make this one g. Okay. If I want the area between those two curves, so what's underneath the blue one and above the pink one, literally like between the two curves, we're looking at this right there. So one thing we have to know is where they intersect, so we can say we're doing this from A to B. It would look something like that. Okay? Does that make sense to you? And so I want to find the area between the two. So what I would do is I want to find the area. So find the area bounded by two curves. So the terminology is important here. Area bounded by two functions on this interval from A to B. We're going to have the integral from A to B, right? And then you're going to take f of x and subtract g of x. So what this ends up being is, in general, the integral from A to B. Oh, look what I forgot. What did I forget on here that's so important? Dx, thank you. Dx, forgot my dx there. This is going to be equal to top minus bottom dx. Okay? Top function minus the bottom function. That's why this is f of x, g of x. The top of it minus the bottom of it. That's a very good question. How do we know which one's the top and the bottom? We'll look at that in just a minute. That's why the graphs are very, very important. Okay, everybody okay with all that? You're just subtracting the two, top minus the bottom. Now, what if instead of y equals f of x, we have f equals y of x, like so? Then we could have a graph that looks like this. Okay, we'll make this one f, and we'll make this one g. Okay, and instead of a and b being on the x-axis, A and B are on the y-axis. Right? So when that happens, we are going to have the area, or the integral, I'm sorry, from A to B of f of y minus g of y dy, which means this ends up being the integral from A to B of right minus left dx, or dy, sorry, that would be dy, when you have the change in y. Okay? Everybody okay with all that so far? All right, which means that we need to be able to graph some of these functions pretty easily, right? And these are basic functions. The crazy ones you're going to get to use your calculator for. You're fine. Okay, but what does this thing graph? A quadratic, okay? Does it get shifted left or right any? No. Does it get shifted up or down any? Yes. It goes up what? 3. So I'm here at 3, right? And then is it going to open up or down? Down, okay? And so it's going to open down like this, but I need to know like where it actually intersects, right? So let's substitute in, well, what happens if y is 0, like where, I want to find my zeros, right? That's 3 minus x squared. So x squared equals 3. So x is equal to plus or minus the square root of 3. You agree with that? Okay. So plus or minus the square root of 3. Let's just draw this in and say, okay, so this is negative square root of 3, positive square root of 3. We'll see if we even have to know what square root of 3 is at that point. It's the same thing. It's a quadratic function that graphs a parabola. Does that make sense? Good question. All right, what is this thing going to graph? A line. What is my y-intercept? 1, okay? So 1, that would be 2, and then we're there at 3. So I've got a point right here. It's hard for me to make points on here, so you get a little weird blob. And then what would, so it's going to come through here. What are my y-intercepts here? 1, and that's it, right? I mean, sorry, my x-intercept is what I'm sorry. Where do I intercept the x-axis? What are my zeros? Negative x plus 1, so it's just here at 1, like right there. So it's going to look something like, well, something like this. So do I really, really care about those square roots of 3? I really don't, right? This is my shaded region. I need to figure out what A and B are where they intersect, right? So how do I figure out where two things intersect? Two functions. No. Well, I could on the calculator, but this is a non-calculator question. If you want to know where two functions intersect when you did systems of equations and whatnot in Algebra 1, you just set them equal to each other. So 3 minus x squared equals negative x plus 1. So I want to know these 2 points of intersection. What is A and what is B? So this is a quadratic. I'd like my x squared to be positive, so I'm going to move everything to the right. I get 0 equals x squared minus x minus 2, right? Can you factor that? X and x. What are my two numbers? Negative 2 and 1. That means my x values are actually negative 1 and 2. Right? So A is at negative 1. B, this point right here where they intersect, is at 2. The 2 points of intersection. We good on that? What questions you got about that? Anything? All right, so we're going to take the integral from negative 1 to 2 of the top, which function is the top? 3 minus x squared minus the bottom, which is more than one term, so it goes in parentheses, dx. Okay, we all good with that? So then that gives me the integral from negative 1 to 2 of negative x squared plus x plus 2. Yes? Dx. Can you integrate that? Yes. Is this a pretty simple integration? Okay, so go ahead and integrate that. I'm going to write my integration. I'm going to write it over here. I'll let y'all integrate that little function first, though. Yeah. Right, you wouldn't have to put the plus c because this is a definite integral. Yes, exactly. Is that what y'all got? Yes? Okay. So now we evaluate it, right? Evaluate means we substitute stuff in. So I'm going to substitute in the 2, and this is going to give me negative 2 cubed over 2 plus 2 squared over 2 over 3, thank you, plus 2 times 2 minus, and then open my parentheses because I'm going to subtract more than one term, right? Minus, I substitute in the negative 1, so it's negative 1 cubed over 3 plus negative 1 squared over 2 plus 2 times negative 1. Now, if this is free response, I don't have to do another single thing. Okay? Now, I would have gotten it wrong because I wrote 2 instead of 3 because I'm an idiot. But you don't actually have to do the math, right? Now, should we be able to? Yes. Are we going to go ahead and do this? Yes. And so then negative 2 cubed is what? Negative 8 over 3. Yes. And since it's cubed, it'd be negative either way, but yes, but that does matter. So it's negative and then 2 cubed is what we're doing. Yeah, so either way, you're going to get negative 8 because it's cubed. Yeah. All right, so then 2 squared is 4 divided by 2 is 2 plus 4 minus, all right, negative 1 cubed is negative 1, and then we make it negative and it becomes positive, so this is 1/3. Yes, this is why we have safe stops, but if it's multiple choice, we have to do the math, right? Plus, negative 1 squared is 1, so I get 1/2. And this is why safe stop's so important if you can't actually do the safe stop. Minus 2. Okay, but watch this. When we actually put all this stuff together, I don't have to get a bunch of common denominators and stuff. Because if I just look at my thirds, negative 8/3 minus 1/3 is going to be a negative 9/3, which is what? Negative 3. And then I'm going to mark them out because I just used them. Then I got 2 plus 4, which is 6, right? 6 minus 2 is, oh, plus 2. Yeah, 6 plus 2 is 8 minus 1/2. So we could do plus 8 minus 1/2 and then figure it out from there, right? So this is going to give me 5 minus 1/2. Which is actually 4.5, which is, might be an answer choice, but if not, you get it that far and you know it's 9/2. You gotta know how to convert that. The basic numbers here, yeah. It's not the calculus that's hard. It's the adding and subtracting on this one, right? Yeah, pretty much. It's what a lot of this boils down to. That's why it's the fundamental theorem. All right, we good? What? They're both untied. And I'm going to trip over them, but I keep tying them, and they keep coming untied, and I'm done with it. So, but thank you. I'm going to throw these shoes away, I think. Okay, we're going to find the area bounded by the following graphs. 5 minus y squared. Okay, this is still going to be a parabola, but since y is squared, it's going to be laying down, right? And if, so if it looked like this, so if I had this, when it's a y squared, it looks like this. But this means it's opening upside down, so it's actually going to open like that. And then this, instead of being a vertical translation, is a horizontal translation. Worst case scenario, we substitute in some numbers. If I let y be 0, what is x? 5. So that's why I know I'm here at 5. Like I said, that horizontal translation. If I want to know what happens when my x's are 0, I make this 0. That's equal to y. No. Jesus Christ. 5 minus y squared, I can't believe y'all haven't lost total faith in me yet, or you probably have. So y is going to be plus or minus the square root of 5. Now, it didn't matter on the last one, and nobody's going to make your numbers crazy when it's not multiple choice. But what that does tell you is that it basically looks like this. Well, but curvy. Let me redo it. Actually, let me just take those out, and then I can put them back. Like that. Okay? It looks something like that. That's all that really, really matters at this point. Yes, sir. You can. If the numbers are, yes, you can. If that makes sense to you. Yeah, see? Wouldn't worry about that. Now, this is a line. Can we make it into a line that we understand better? We can make this y equals x plus 1, right? So I knew that this was the square root of 5. So 1 is here somewhere, right? There's my 1. And then my slope is 1, right? So it's going to look something like that. We agree with that? And then I have to figure out what my A and B are. That would be this and whatever this is where these intersect. And I'm looking for this shaded region. But this time I want this A and B, these are y values, not x values, right? Because we're on the y-axis, and once you graph it, you can kind of see that, no biggie, right? So this is A, this is B. But I'm going to set them equal to each other again. So 5 minus y squared is equal to y minus 1. So we'll move everything to the right. 0 equals y squared plus y minus 6. So 0 equals, and then I can factor. What are my two numbers? 3 and 2. Positive 3, negative 2 in there. So my y values are a negative 3 and a positive 2. So this is negative 3. This is positive 2. So that tells me what I'm integrating from, right? Gives me my limits of integration. Yes, ma'am. Usually that's like a linkage error, and you'd get some points, but you might lose a point somewhere because your stuff doesn't flow. Does that make sense? But it wouldn't keep you from getting everything else. Yeah, and let's say here you had a negative 2 and a positive 3. You'd lose a point here, but as long as you used your wrong numbers correctly for the rest, you'd be fine. Okay. All right, so now we're going to integrate. Right? So we're going to integrate from negative 3 to 2. And which one goes first? Right. So 5 minus y squared minus then the other one, which is y minus 1. And then we have to make sure that we put on here dy, that we don't put a dx because it's the derivative with respect to y. Yes? Uh-huh. The one that's the bounder that's on the right. So this is the one we graphed right here. This area right here is what I'm finding. So the boundary of the area is here and here. The right boundary is this one. The left boundary is this one. Okay? Yeah? All right, so that means I'm going to integrate from negative 3 to 2. This is going to give me negative y squared minus y plus 6 dy, I believe. Okay, and then I'm going to do my integral over here. So y'all go ahead and integrate that thing. We'll see if we agree. Now, y'all see if you can evaluate that by hand. I'm going to shove my shoelaces into my shoe so I don't kill myself. Don't sit there and wait on me. Is that right? Why is 6 negative? Why is 6 negative? That's a very good question. 6 should not be negative. I wanted to see if you were paying attention. Good job. No, I just messed it up here. When you square this, it becomes positive, then it becomes negative, but then you got to subtract the negative. That's why that's positive. I just wrote the wrong sign down. Okay, now keep going. Let's use our basic math skills. You got this. Okay, I'm just gonna, yeah, it's a safe stop, but what if it's multiple choice? What if, okay, so 18 plus 9, that's 19. I think I got 19. Right? Is that what you got at that point? Well, I'm going to show y'all something that works on this one and actually works on a lot of things once you finally get the answer. I'm going to show you how you could write this part here differently. And it will actually help you. No, that's only multiplication. What'd you get? What'd you get after that? Y'all don't like the 19, right? So let me show you this. I'm going to rewrite this as I brought it down here. I'm going to leave that negative 8/3 as negative 8/3. Then that was actually minus 4/2, right? Which we know is 2, but I'm going to leave it and I'm going to show you why. Plus 12, okay? Then minus, this is really 27/3, okay? And then plus 9 halves, and then plus 18, okay? So same numbers, I just didn't reduce my fractions. You with me so far? So now I'm going to combine things a little bit at a time. Negative 8/3 and negative 27/3 becomes negative 35/3. Am I right? Okay. Negative 35/3. Then I have negative 4 halves and 9 halves. That's going to become plus 5 halves. Yeah, please stop me if any of that's wrong. And then plus 30. Now, I'm still at the same spot, but my numbers are better, and some of my fractions are already semi-combined, right? Am I still going to have to get a common denominator of 6? Yeah, I am. And so, but to get this to 6, that's just going to become negative 70 over 6, right? Plus, that'll become 15 over 6, and then plus 180 over 6, right? Then 180 minus 70 is 110, plus 15 is 125 over 6. So by leaving them, when you have fractions, by leaving them, even when you can reduce them like these, you basically can combine some more fractions and you have some of them already taken care of. Does that make sense to you? I mean, that's just a different way to look at it, but either way, do we also need to do this one here? If I need a common denominator of 6, right? So I double that, I get negative 16 over 6. And plus, what would that be, 27 over 6? And then you don't want to multiply 19 times 6. What's 20 times 6? 20 times 6, right? It's 120. That's 26s. I only want 19. So I take my 120 and I subtract 6, and that gives me plus 114 over 6. I mean, you can do it the other way too, but hey, whatever works for you, okay? And then you combine all that, you're going to get 125 over 6. If it is free response, stop here, okay? Stop there. Substitute them incorrectly, unlike what I did on the first one, but stop there, okay? We good with that? Absolutely. All right. Let's look at some trig stuff. Oh, no. All right, we got sine and cosine. Do you remember, because you have to, what your parent functions for these look like? Sine looks like this. Cosine looks like this, right? They basically look the same if you keep going. One is just shifted left or right of the other. What is the period for sine or cosine? To make one little squiggly like this, I'm going from 0 to where? 2 pi. Very good. What is my maximum here? No. 1. And my minimum is -1. Okay? That's what's happening there. Because the biggest sine value you can give me is 1. Smallest is -1. Think of your unit circle. Okay? All right, so we're going to draw that on here. We've got that. Okay? And then let's think about what's actually happening with cosine before we just kind of slop it on there. Whenever sine has a 0, cosine has a maximum. Whenever sine has a maximum, cosine has a 0. Okay? And so here's a 0, then my cosine has a minimum. There's 1 here. Because we want this to be, I mean, it doesn't have to be crazy accurate, but if we want to be able to figure out anything that's happening, we need it to look like we at least made an attempt here. So that's what it looks like when they're both graphed together. Okay? So here is the shaded region. Yes? All right, so then we're looking for where they intersect. right? So when is cosine the same as sine? When does the cosine value of an angle give me this is the same as the sine value of an angle? What angle is it? Which one is your sine and cosine is the same? You can have, your options are like, for your values are 1/2 square root of 3 over 2, square root of 2 over 2, pi fourths. Pi fourths is square root of 2 over 2 and square root of 2 over 2, right? So this is pi fourths right here. And then the next time they're the same is in the third quadrant, and that would be this, which is 5 pi fourths. Just like so. Okay? All you have to do is think about your unit circle, right? Just go through that. All right, so now we're going to integrate from pi fourths to 5 pi fourths our, which one's the first, which one's the top? Is that sine or cosine? Which one's the top? Sine. Sine of x minus cosine x dx. Can you integrate those? Yes. All right. So when I integrate sine, what do I get? Negative cosine. When I integrate cosine, what do I get? Sine. It's technically, oops. Yeah, so negative sine because that's there. Okay. And then I integrate from pi fourths to 5 pi fourths. Evaluate. I'm sorry. Evaluate. So, and you can look from this graph right here. The sine of 5 pi fourths is square root of 2 over 2. It's where they're the same. And then, I'm sorry, that's pi fourths. And then 5 pi fourths is negative square root of 2 over 2. So the cosine of 5 pi fourths is the negative square root of 2 over 2, but that makes it positive, square root of 2 over 2. Same thing happens for sine, plus square root of 2 over 2. Minus, and then cosine of pi fourths is square root of 2 over 2, but I got to make it negative, right? So negative square root of 2 over 2 minus sine of pi fourths is square root of 2 over 2, but I got to make it negative, so it makes it positive square root of 2 over 2, right? So what happens here? Oops. Wait, I did that wrong. What did I do wrong? Oh, I was making it negative twice. That's what I did wrong. I put a minus and then I was like, we got to make it negative. That's square root of 2 over 2, then we make it negative. Okay. I made it negative twice. So what's the square root of 2 over 2 plus the square root of 2 over 2? Which is just square root of 2, right? Minus, and then this is going to be negative square root of 2. So what's my answer? Two square roots of 2. Yes. Cosine of pi fourths is the square root of 2 over 2, but that makes it negative. Minus sine of pi fourths.
So the sine of 5 pi fourths
is negative. But that was this right here. Sine of 5 pi fourths is negative square root of 2 over 2. Yeah. And then we made it positive. I know, I confused you when I made it negative twice here. Sorry. We good? Okay. Come prepared for a video tomorrow so we can do some more of these together.